All right, so now I have all of my data here. I've got 36, 46, 56, 66, and 76 grams for stationary and oscillating. So now what I want to do is just make a new sheet, and I'm just going to have this be stationary. And what we want is we want to take the data from all of these sheets. So we're going to have the mass in kilograms and y, which is our equilibrium position, in meters. And what I can do here is I can reference a specific sheet. You can also see that since I hit equals, it will let me just go over here. And I can go to stationary, and I can pick, that if I want. And I can say that this is equal to that. And you can see that what it does is if you want to reference a different sheet, you just, in quotes, say the name and then exclamation point and then the cell. Once I have those there, I can copy and paste this whole thing. If I try to just drag this down, what's going to happen is it's going to be giving me nothing. And that's because, it'll give me something there, but that's because I'm then referencing different cells, because this is supposed to be E3 and E1, and you can see the next one is E4. So really, I want this to be E3 every time. So what I can do is just copy what's in the actual top part and then paste that into each of these cells. And I'm going to want 5 of these. And then what I can do is just change the title of the sheet that it's getting the information from. I'll show you in a second. This is a little bit tedious having to copy and paste it so many times. There's probably a better way, but I'm just going to do it like this because not that many cells. And so what I can do here is just change this to 40. And that should have worked, but it didn't for some reason. E1 and E2. Oh, I switched from... Yeah, so I switched the position, which is something that you don't want to do if you're going to do it like this. You can also just copy and paste the values, each one individually. But yeah, so now I'm going to have to change all of these. That's all right. Anyway, I can now, if I would have kept it consistent, I wouldn't have to change that. But I can now just change each of these to the name of the sheet that it's from. Do the same thing. These didn't move, so I don't have to worry about that. So I can just change this to 46, this to 56. I mean, it's 55.9, but whatever. Change these numbers. And so now I have all of my masses and all of my positions. Once we have our mass and our position, we also want mass times gravity in newtons, which is equal to this cell times 9.8. And I'm just going to use 9.8 because in Florida, that is actually closer to 9.8 than 9.81 for most of Florida, as far as I know. So then we have all of our weights. And then we want to make a graph. And we want on the x-axis, we want to use the scatter. On the x-axis, we want the position. So we'll use this column. And on the y-axis, we want the force, which is this. Oh, and I messed it up. And on the y-axis, we want the force, which is this column. And so that is our graph, and we want to add a fit. And so the negative of that value should be our spring constant, which we got negative 4.72. Now, the spring I was using has a spring constant of about 5, so that is fairly accurate. You will have two different springs. One will be about 5, and one will be about 8, if I recall correctly. So hopefully you will get something around those values. And yeah, that's it for determining the spring constant based on the stationary trials. Now we'll make a new sheet for the oscillating. And so for this, we want omega, which is in radians per second. Oh, I didn't mean for that to be capitalized. And we want m in kilograms. And so what we can do is we can do equals and then go to another sheet, the oscillating sheet, and we want omega, so that would be omega. Hit enter, and then hit equals, go back to that same sheet, and that's the mass. Hit enter. And again, we can copy this, paste it there. I don't know why the font changed. Is that going to happen every time? Okay, well, I'm just going to put it in there so that the font doesn't change. Actually, if we put it twice and then drag it down, it will just, oh, will it not? Just, okay. I thought it would just stay at 1, but then it goes 3, and then 3, and then 5. All right, well, whatever. We can just type these in. 1. 1. And drag these down. 1. 1. 1 and 1. And so then, again, we want to change the sheet so it's the one for the appropriate mass. Oh, why did I do 4 twice? So for this, we're using the equation that omega is, or k is equal to m omega squared. So really what we want to graph, if we want k as the slope, is m on the y-axis and 1 over omega squared on the x-axis. So I have omega, and I want 1 over omega squared. And so what I can do is equals 1 over, and then this squared, and I think it would be fine without the parentheses, but I'm just going to use parentheses just to be safe. and drag that down. And now I want to make a graph again. It's going to be scatter again. The x is going to be these values. And the y is going to be these values. And again, we want to add a trend line and use the equation. And there we get 5.57 for the spring constant, because the slope again should be the spring constant if I graph m versus omega squared. We could, also calculate a spring constant for each of these individually, but we're just using the graph and the slope as a method of basically averaging them. If I wanted to just calculate k, I would say that it's equal to m times omega squared. And I just get a different k for each of these, and then I could, average that if I wanted. But this, doing it the graphical method, both, averages it for us and kind of weights the average by the trend of the data and shows that it follows the expected equation. Because we expect this to be linear, we get something linear. So that means that the theory is actually working at least fairly well. I hope that makes sense. There's a little bit more that I'll go over in a moment, but that is how you find the spring constant with the two different methods.